So, combination circuits, we've looked at these a little bit before, but it's basically when we've got a number of series and or parallel. So you can have, usually it's a combination of both, but you can have a combination series that's just got a combination of parallel components, for example. So it's when you need to break a circuit up into segments to identify resistance, current or voltage. Usually they're more complex and they take a little bit more planning, a little bit more solving to figure out. So I've got a nice simple example up here on the board. I'll just raise that up a little bit. Okay. An example on the board which will help us see how we should go about solving combination circuits. The best process, because there's no step 1 you do this, step 2 you do this, step 3 you do this. The best process is to break it into manageable segments and sort of think like you are a piece of current passing through the circuit. Who thinks they can identify where I should make my first segment on this?
Like the top part of the parallel, so the two.
So this line here? So what I like to do is I like to circle or to identify my parts and call that segment A, for example. And then in my head I'll label the resistors. You may or may not want to do this, but I will write RA. Now what type of circuit is RA? RA, just that line.
That's a series.
So what's the equation for resistance in series?
RT equals R1 plus R2.
Yep, so RA equals R1 plus R2, which equals 2 ohms plus 4 ohms. So RA equals 6 ohms. Very good. Now what essentially I've done there is that instead of having 2 resistors in my head, I now can treat this like a single resistance that has 6 ohms worth of resistance. So every time I do one of these, what I'm doing is saying if I replace those 2 resistors with one resistor, how big would that resistor be? 6 ohms in this case. Where should my next segment be? Because am I ready to find my resistance total yet? What do I need to do?
You need to figure out the total resistance of the top RA, RB, which is 3.
Yep, so I'm going to make RB this segment here. Now you may not want to draw all over yours. Why do you think I'm doing that? If I was doing this at home by myself, I wouldn't do this. I'm trying to show you where the different segments are. Now what type of circuit is RB? Parallel. So what's my equation for resistance in parallel? 1 over RB equals?
1 over R1.
Well, why don't we call that R3 plus 1 over RA. I see why you said 6 though. R3, I'm just going to call this resistor here resistor 3, that's resistor 1, that's resistor 2, and this will be resistor 4. Just so that when I'm putting them in my equations, I know which one I'm talking about. Why have I made it RA here?
That's resistor 1 and 2 added together.
Yep, so that's 1 and 2 added together. That's why I found out what my RA was. So I want RB, 1 on RB equals 1 on 3 plus 1 on 6. How do I add those two together? It's 1 on 9, right?
Yep.
Which makes the resistance 9 ohms. Is that how it works?
No.
What should I do?
You got to find the lowest common denominator.
What's the lowest common denominator? How do I make both of those have a denominator of 6? 2 over 6 plus 1 over 6 equals 3 over 6. But that's what 1 over RB equals. Is there another way I could have done that? Is there another way? I know that some of you might not use lowest common denominator. Some of you might use cross multiplication. Either way is fine. It does not matter. Particularly as you'll simplify in this next step. Then you flip it. I want RB. So I need to flip the terms, which is 6 over 3 ohms, which equals 2 ohms. So what I'm saying is everything in that box titled B, I can treat that like a singular 2 ohm resistor. Is it now time to calculate RT? What does RT equal?
RT equals R1 plus RT.
Do it in a different coloured pen so we can see.
Yeah.
We go RV,
RT equals what?
RT equals
Just RV, so 2 ohms.
Plus
R4.
Plus RA.
Very good. Which equals 2 plus
4 equals 6.
Now, that's a really what I would describe as a gentle combination circuit. The reason it's a gentle combination circuit is because there's only a few components that you need to consider. And secondly, I've kind of scaffolded it in a way. I've scaffolded it because I've given you, I'm just going to get rid of these. I've told you you need to find RT, which has sort of told you what you need to do to find it, to find your value. As you get more fluent with these, the question won't be set up to say find RT. Instead, I'll give you a circuit and I'll give you a piece of information that's missing. Like I might say, what's the current? Now, I'm hoping that every person in this room could tell me what the total current for that circuit is.
2.
How do you find that, Hannah? You're right, it is 2.
You go
Voltage divided by resistance.
Voltage divided by resistance, which is a rearrangement of what law? Ohm's law, V equals IR, okay? Now that's not that difficult. That's still another step because I haven't scaffolded the question. If I want it to be even more difficult, I might give you the resistance. I might give you the voltage there, not voltage. I might give you that as 2 amps. And I might say, what's the value of resistor? R1. Okay? So as we get through, you'll learn how to approach these problems very well with different strategies depending on what you're looking for. What's the trick, Noah? What's the trick to solving these problems?
Break it up into manageable parts.
Break it up into segments. The other piece of advice I'll give you is that there is often a really efficient path, but providing that you're finding out more things about your circuit, you're not going down the wrong path. So just keep finding stuff out about your circuit. Find out what the total current is. Find out what the total voltage is. Find out how much voltage goes through this wire. You can figure it out. Does that make sense? You just need to keep being persistent because it won't always unravel itself. That's an introduction. We'll give you some examples now.